Hi everyone, I'm Parisa.
I'm Claire.
Um, we're showing you Project 6. So this is our graph demo code for Project 6, but basically in essence, we coded our own version of a GPS. So in this, we can type in a start and end city, and then this in essence will calculate and display the route that we can then use to travel between these two cities, kind of like a simplified Google Maps. So we're going to click on this button here. And then over here, it says, okay, enter your start and end cities using their two-letter state abbreviations. So I'm from Richmond, Virginia, and I'll say Richmond, Virginia, and then Claire.
Yeah, and then so we hit enter for the start city. And then afterwards, I'm from Seattle. And so we can then type in Seattle and then type in the state that it's in. Yeah, and then hit enter again. And then now the code has stored both the start and the end cities. So if we hit enter one more time, it'll start to run and it'll start to calculate and display the nearest or the fastest and shortest route in between the two. So yeah, if you could display the map.
Oh, yes. So over here, if I want to go visit Claire back in our hometown, I have to go all the way along this route from Richmond, Virginia to Seattle, Washington. But this displays the shortest route taken between any 2 points. And ultimately, we're not looking at the exact coordinates themselves. We're looking at the vertex closest to the coordinates and looking at the distance between them.
Yeah.
And
So what happens is our code will first take the input cities and compare them and see which point on our graph of intersections and roads is the closest to the coordinates of the cities that we put in. And so once it figures out which point on the graph is closest, it will then start searching through all of the neighboring points or nodes in order to figure out the fastest connecting route in between these two cities. And after figuring out which point on the graph is closest to the input cities, it will then use a breadth first search to look through the graph and figure out the shortest route. And it's guaranteed to be shortest because the breadth first search is a method that guarantees it to be the shortest. Um, and lastly, as the breadth first search is going on, it's also keeping track of the total distance. And so it will eventually input a list of the path from Richmond to Seattle, and it will add the weights in between each point together, and that will give the total distance that's required to drive from Richmond to Seattle. So as you can see from the code, it shows that the route distance is 2,722 miles, which is an extraordinarily long amount. And we can also see the total amount of time that it took for us to calculate this route. And as you can see, it's 509 milliseconds, which is pretty good. We'd say quite proud of that. And
yeah, that's that's our project. And we think though, one reason why this amount of time it took to calculate it was moderate and not necessarily worse than it could have been is because when we constructed our hash map for the graph, we had used a hash set compared to like, I don't know, an array list. So that's one point of thought. Maybe another way, hopefully, if we wanted to improve on accuracy of this project would be taking it coordinates from multiple data repositories, and to expand it we could look at something like a world map instead of just the USA graph. But yeah, this is our project so far. Thank you for listening.